Alrighty, we finally arrived at the part of the program that's known in science as nut cutting time. Okay, and what that means is we've taken all these crazy, wonderful, imaginative ideas that we call a paradigm, and we need to reduce them to practice. That's the whole point of having a paradigm. Okay, if we can't reduce it to a actionable uh, process or logic or math, then what use is it? We're just back to Aristotle where we're just telling stories. Okay, so we need to be able to reduce these things to practice, make them actionable. Okay, in the case of the scientific paradigm of the genetic code, this seemingly should not be that hard to do because this paradigm is so bad. All we have to do is recognize how bad it is and then just start saying the opposite. And all of a sudden we have a better paradigm. But that's not happening. I just can't believe that what's happening is actually happening. I mean, I always thought that science was a process of trying to figure out the difference between right and wrong. Well, that's not what science is at all. Science is this incredible belief system where people, there's a joke about, the, the, the fight is so vicious because the stakes are so low. Well, that's true. I mean, they fight about nothing, but when something significant comes along, they won't even discuss it. Um, so in this case, I've been doing this now. I'm well into my third decade, and there a clear pattern emerges. If I discuss this or describe this to somebody who has no scientific training whatsoever, or perhaps is lightly trained and they've actually been taught the genetic code, but they don't have a dog in that fight, they will immediately get it. You can explain it to them in about 2 minutes. They'll get it, but they'll like it. And they can find uses for it, okay? And that's fabulous. That's a wonderful thing. But on the other side of the coin, you can take the smartest son of a bitch in the world, train the hell out of him in science and math, and teach him the genetic code. Hell, he may feel like he's the world's leading expert in the genetic code. And not only will he not understand this, he won't listen to it. Okay, he won't allow it. And so it's almost like a binary test. If you try and explain this to somebody and they like it and get it, you can know they're not a scientist. If they don't, it doesn't matter what kind of science they're in. They don't have to be in biology or molecular biology. They could be in physics or anything. They'll go through these various stages. It's like the stages of death. The first stage is fear. You can see it in their eyes like a deer in the headlight. They become afraid that maybe they don't know something or that maybe what they know might be wrong. And that very quickly leads to anger because fear and anger are the same thing. So they get angry and they may even start yelling at you. And that's happened to me several times. Okay. But after this anger phase, then they cool down and they go into this intense period of gaslighting. They don't want to hear what you have to say. What they want you to believe is that you're crazy, stupid, and wrong. Okay. And that's all that matters. They gaslight the hell out of you. Well, and sometimes, especially if you go online, they'll call you these horrible names. Well, back at you, pal. I mean, I wear my badge of heresy. My title as a heretic is a badge of honor. They wear their badge of ignorance. They'll even say, I don't know anything about this. Well, you're a molecular biologist. This is not my field. No, this is your field. It doesn't even matter what field you're in. Everybody in science should know the genetic code and they should know it correctly. Okay, so this shit's got to stop. I mean, it's just got to stop and it will stop. Okay, what's going to happen is, I mean, if you go to somebody, I mean, these people are professionals. They're getting paid to do this. They get paid to teach children this. So if they're paid at the high school level, you can actually talk to them and maybe convince them. As you go up the chain, as they get higher and higher, as they become bigger influencers, I mean, they become more obtuse and more obstinate. You can't even talk to them. They won't even listen. Okay? So this has got to stop, and it's probably going to change from outside of science. There's going to be an influencer. In my dreams, it's going to be Elon Musk. I mean, Elon Musk could figure this out in 2 minutes. If he likes it, all he has to do is make a tweet or a X post, whatever they call them, and he could just say it's right, and then all of a sudden, it's right. Okay, we need an authority, an influencer to say, hey, quit the bullshit. Okay, stop the bullshit. So The problem that we have when we try and talk to a scientist is that he believes very strongly that he knows what he's talking about. Okay? And he doesn't. Okay? And the reason he doesn't know what he's talking about is the people who taught him this, the people who invented this, didn't know what they were talking about. Okay? So step one is to find somebody, anybody who knows what we're talking about. Okay? Well, what we're talking about is a code. So that's a good step. Let's treat it as a code. Okay? Well, they say, well, it is a code. Well, yeah, it is. So let's examine exactly what that premise is. They're saying it's a code. All codes are objective. Okay? They're not subjective, they're objective. So we can find an object of the code on which the logic of the code is based. So let's do that first, okay? What's the object of the simple, linear, deterministic code of life? Well, it's this right here. This object defines the code. Well, that's seemingly impossible, but it's true, okay? What they did was they got confused about cause and effect. They went out and they did an experiment that they had planned. They said, we're going to line up these molecules and they're going to cause these molecules to line up. So they did that. It was fabulous. It was wonderful. It's a great experiment. Okay, the results of that experiment can be described by this logical relationship. It's 3 makes 1. 3 of these make 1 of these. Okay, well, they got confused. Okay, this is the result of an experiment. They generated data. Those are the effects of the code. The code caused those results, but they got confused. They said these results caused the code. So all we need to do is say 3 makes 1, 3 makes 1. Just keep saying it. 3 makes 1, 3 makes 1. This is their code. Okay, well, that's just logically incoherent. Who believes that this could be the logical basis of all life on Earth? Well, you know, it's like a dog with a bone. Once they got it, they just kept saying more and more and more crazy things. And each thing they said was more logically incoherent than the last. And then they started testing these things and they started failing. So it's like the geocentric solar system. So they have a circular orbit, and when it doesn't conform to that, they just add an epicycle. So they had one circle and then the rest is epicycles. Okay, and then they say, well, there's exceptions to every rule. Yeah, but your rule is the exception, and all your exceptions prove the rule. I mean, you've got it all backwards. So the problem is A, they think they know what they're saying. B, they think it's been proven. And C, they can't see any alternative. This is the only alternative. Well, there's thousands of alternatives. In fact, any alternative would be better than that, because it's just such an incoherent idea that it generates nothing but false statements. So we could create the contrarian paradigm that just says everything your paradigm says, I'm going to say the opposite. Well, the contrarian paradigm works better for making true statements than the paradigm. So that's a good sign that your paradigm's messed up and you don't know what you're talking about. So one alternate paradigm would be, let's pick a different object. Well, I picked this object. And the reason I pick it is because I already know it's right. Okay, how do I know it's right? Because it's a machine that emulates the manufacture of a non-Euclidean field. Well, I already expect the code to generate a non-Euclidean field, because it's got to be more complex than gravity, which is a non-Euclidean field. And it's perhaps at least as complex as quantum physics, maybe a little more, maybe a little less, who knows. But it's a non-Euclidean field, so we can't go from non-Euclidean field, skip over with this, and then go to other non. I mean, there's got to be a bridge between there, and it's got to be a non-Euclidean field. Well, that's why I invented this damn machine in the first place, was I was imagining a symmetrical way to make infinite points in space, an algorithmic way to generate this universal graph paper. Well, all I needed to know was the molecules in this table operate this machine perfectly. That's all I needed to know. I instantly knew what that meant. This language is the machine language of this machine. This machine is emulating the genetic code. Okay? It's not that hard to understand. Okay? You could get it just like that. It's really a code. There's logic, there's math. Okay? These molecules didn't create this code. Okay? These molecules were created by this code. Okay? These molecules couldn't have been there when the code started operating. So we need to be able to put any molecules in this code and they will generate the molecules in this table. Okay? The code makes the molecules. The molecules have to learn how to be this code. Okay? That's just how evolution works. That's natural selection. Life isn't selecting, it's not starting with symmetry and building, chaos. It's starting with chaos and building symmetry. It's selecting from a large set, it's selecting things out of it. So we need to think in terms of creating information, creating codes. Okay, so the very first thing you got to do if you want to start talking about a code is you got to diagram your code. So let's do that. Here's their code. Well, let's diagram it. We have three things in this code. Now, that's it. Okay, so there are three variables. This is a variable. That's a codon. These are variables. So we have three of these, and we have one of these. So this code, now the code is the set of these variables. So this is the code. There's two sets of variables. There's a set of nucleotides and there's a set of amino acids. Okay, so this is the diagram of the code. Now they believe that there's only one codon. Okay, they believe that there's only 4 nucleotides. They believe that there's only 20 amino acids. These things are empirically false. When they explain their own code, they invoke 6 nucleotides and more than 20 amino acids. So right out of the gate, they've gotten something wrong. Well, they've gotten everything wrong. Okay. Now, you can't wire these things together. This is like a neuron. Okay. You can't. Okay. A neuron doesn't generate any information unless it's in a brain. You can't reduce the brain to the information of the neuron. The neuron, you can't even derive the information of the neuron until you have the structure of the brain. In order to get this, you need to have at least 2 neurons. So you got to put 2 of them together to ask what information. It's because it's a symmetry group or set. You can't build your brain from one neuron. Well, you can't build your code from one codon. Okay, you're going to need to create a network of logical relationships because we know that the code is a complex network of logical relationships. It's a fractal network. Okay, it's going to build information in layers. It's a fractal code. Okay, it's logically structured, and it's going to create logical information which will be instantiated or manifest as molecules. It's molecular information. It's purely spatial. You can't remove space out of the code. Okay, it's purely symmetrical because the information is derived by selecting things out of symmetry. We're going to create the information by selecting things out of symmetry. So we know that this is wrong. It's hokey. It can't work. So the next thing is, all right, if this is our object, how do we diagram this code? Well, as luck would have it, Gamow almost got it right. He says, look, given the idea that there's 4 nucleotides, we can break down spatial symmetry into 20 sets. Okay, so let's call that a codon. One set, so one set of 3 is a codon. All right, so now he's defined his codon as a set of 3, but it's cyclical. Okay, it's unordered. You could say red, blue, blue, or you could say blue, blue, red, or you could say blue, red, blue. Okay, there's more than one way to generate this codon, this set. The set is unordered. Okay, now what he predicted is that these 4 nucleotides would generate this set. So he breaks the symmetry down to 20, but then his next prediction was that other set of 20 will preserve this symmetry. So we'll be able to put each one in each codon. Now, what he failed to understand was, what he could have easily done but didn't do was he should have said, this set creates a set. So just like you could take the example of a triangle as spatial symmetry, you could take the example of 20 triangles and make an icosahedron, or the points of a dodecahedron. Either one, they're equivalent. So he created a set of 20 sets. He needed to create a logical set out of those 20 sets. Okay, and then since life is breaking the symmetry of space using 4 down to 20, then instead of preserving that symmetry with those 20, what life is going to do is perfectly break the larger set with those 20. So these molecules are physical manifestations of broken symmetry. That's where they derive their information. So this table does not dictate where these molecules are going to go. It predicts where they're going to go. It's based on the probability. So instead of thinking of it as a totalitarian system that says these three must be this one, it's more like a dream. There is no table in reality that these molecules reference. It's like a thought. They say, I think if these three are probable, then this one should be probable. And so it predicts that it's going to happen based on pure probabilities. It's just like the table is like a molecular dream, okay? And these associations are not fixed, they're probabilities, okay? Well, this makes perfect sense. And you say, well, where's your proof? Well, this prediction that Gamow made was perfectly wrong. So if he would have just changed that one premise, it would have been perfectly right. Well, just imagine if he had done that. If he had taken this damn thing and put it together and said, this is my model, we wouldn't even be having this discussion. We would never start with this and trade it for this. Okay, this is just stupid. We wouldn't go from smart to stupid, especially when it's been proven. He could have proved that this was right. We can prove it now. But I'll go you one further. I mean, this guy here, everybody's familiar with this. Kepler. This is a hypothesis. He built a machine and made a hypothesis. Here was his hypothesis. I give you the proposition in words just as it came to me at the very moment. The earth is the circle, which is the measure of all. Well, of course, he thought at that time that orbits were circular. Okay. Construct a dodecahedron around it. The circle surrounding that will be Mars. Round Mars, construct the tetrahedron. The circle surrounding that will be Jupiter. Okay, round Jupiter, construct a cube. The circle surrounding it will be Saturn. Now construct an icosahedron inside the Earth. The circle inscribed within that will be Venus. Inside Venus, inscribe an octahedron. The circle inscribed inside that will be Mercury. Okay, what he's doing is he's looking at circles on maps and he's measuring lines. Okay, what he didn't know was, don't start with circles and lines, start with spheres. If he'd have done that, he could have done it all with 2 lines. He could have built this machine. He built this machine. You can see he made obvious mistakes in his thinking because he didn't know he could build this machine from just 2 spheres. If he had built this machine, he could have said something crazy like, this machine will predict the logic of life. And then however many years later, 200, 300 years later, we would have proven that he was right. He could have had this machine, said, hey, this is going to be the genetic code. They come along, do these experiments. The experiments prove that he's right. Okay? These scientists say, well, you're going to need to prove that. I'm like, look, you're going to need to prove this. Everything you do and say proves this is false and proves this is right. They say, well, this is just a numeric coincidence. Are you kidding me? What do you think that science is? I mean, that's all that Newton did, was create a numeric coincidence. I mean, what are you saying? Numeric coincidence is the ultimate proof. I mean, you can't even imagine. This is a logical isomorphism. This is not a numeric coincidence. We can logically create a language that operates this machine, and it's isomorphic in every way with the codon table and the genetic code. I mean, okay, so you take these damn codons that they've got, okay, and you say there's one, and that generates 64 of them. Well, you can just put them all in a bag and shake them up and arrange them however you like. You know, every codon is the same as every other codon. There's just one codon. The only difference is we're going to put values that we're going to instantiate the variables. This is like an object-oriented program. These are objects. This is your object. This is my object, okay? Well, then, for sheer convenience, just human convenience, we're going to make a graph. We're going to make graph paper of all 64 codons. So here's your graph paper. This is it. This is the codon table. But this is a graph of this code. This table adds nothing to this code. This code generates this graph paper. Okay? This is the wrong graph paper. All right? Once you start filling in the actual values, this graph is purely subjective. All you're doing, you could take 64 of these and line them up. Well, there's more ways to do that than there are the number of atoms in the universe. Okay? So this is the graph of their code. This is the graph of their data table. They took this data table and they started talking about it like it's a code. It's a data table. Quit doing it, okay? On the flip side, what we're able to do is generate this graph, okay? That's a mathematical graph. This is a mathematical graph. But our object, when we did this, was A, to optimize it. We want to reduce it to the most optimal form. And B, we want to maintain the symmetry of the graph. This is not a data table, okay? This is a graph of a code. We can use it as a data table. We can put the same data in it. We can predict the experiments that you're predicting in the exact same way, but we can also make logical conclusions about the actual code. What we're doing is we're trying to find a way to logically graph this object. This is an objective code. Now, when we start to put values into the code, what we're doing is we're instantiating variables. Okay, so we need to have variables. We need to actually have variables in our code. There's not enough variables in this code, and we don't even understand the ones that we've got. We need to create a logical structure of a code before we start holding court about what a code is. Okay? And it's seemingly obvious if we already know that this object emulates the code that we're trying to describe, then this should be a much better object to pick to graph the code. Because all you're doing when you take this graph, okay, when you take this object here, which is a data table, it's a graph of data. What you're doing when you use this is data analysis. Okay, they're analyzing the data and they're making comments. They're saying it's arbitrary. No, the graph is arbitrary. The data is not arbitrary. Okay, they don't see any symmetry. They don't see any information because there's none here. There's no symmetry. There's no information. Okay, the thing of it is that they were told right out of the gate. They were told that's not a code. Okay, they said they didn't care. They said we're not going to call it the genetic cipher. It's really a recipe. So what this makes this is a hoax, because they knew it wasn't a code, but they called it a code. That's a hoax. So, you know, science is a victim of the world's, this is the greatest scientific hoax in the history of science. They're going around talking about this like it's a code. This is a data table. It's not a code. This is the code. This is the genetic code they're talking about. This is stupid. It fails. We need to reject it. We need a new paradigm. So we can go to this paradigm. And now all of a sudden, we flip from saying things that are false to saying things that are true. They're not just true, they're useful. Because by analyzing the data with a correct, mathematically correct data table, which is what this is a graph of the logic of the code. It creates a mathematically correct data table. We can analyze the data in this, and we can make observations about life that are true and useful and powerful. They're amazingly powerful. You'll be shocked by what you can say about life based on knowing the mathematically correct graph of the code. Okay, so, at the very least, these people who are experts, who are professionals, they don't know what they're talking about. And they'll even admit it. They'll say, this is not my field. And it doesn't matter what field they're in. Well, please stop teaching this. Quit accepting money to explain things to children that you don't understand, that you know are empirically false and logically incoherent. Just stop. Okay? If you don't have enough interest in what you're teaching to take the time to understand it, then quit doing it. All right? At least get the hell out of the way so that some people who do care about true and false, who do care about understanding nature, who do care about the validity of scientific reasoning, have a chance to not confuse children. And then, when you explain it to them that way, they say, well, you're just making this too confusing. I mean, the kids will never understand it. Trust me, they will understand it. Okay. They say, look, we need to keep doing this because we want to keep from confusing them with all these details. I'm like, so you're going to prevent confusion by starting with confusion? I mean, this is the kind of logic they use. Okay. They have a belief system. It ain't going to change. You're not going to change it. You cannot make them change this belief system. The outside world is going to have to force it to change. The scientists aren't going to change it. Okay? And this is not unusual. This is how it happens. I mean, these guys get really angry. And they always do. I mean, they made Galileo stay in his house for 8 years. I mean, my wife says, be careful, they're going to kill you. Maybe they will. I mean, they sure as hell can't prevent me from getting a job, because I'm not applying for a job. I'm not applying for grant money. I'm not even offering to get paid to teach this. I'm teaching this out of the goodness of my heart. So now that we understand the difference between stupid and smart, the difference between right and wrong, the difference between a code and information and complexity and simplicity and linear and data, I mean, we need to start thinking about this damn thing logically. This is the most powerful force of nature. This is life, okay? It is a non-Euclidean field. It is causing these atoms to do this highly improbable behavior. It is learning how to do this, okay? This is a highly intelligent spatial computation system. The code is writing itself. It's iterative self-reference. It's a fractal. Okay. We aren't going to understand that until, while we're stuck on stupid. We got to get unstuck on stupid before we can understand what's actually happening. So in the next video, we're going to start doing some math, some real math, where we talk about breaking symmetry and creating information.